So I'll go ahead and just start recording now. Sorry about the delay for getting this started. Did not expect the HDMI cable not to be working the day after it worked. Although maybe it has something to do with the fact that I dropped my box. Let's switch that. Hopefully it's better to see now. Hopefully. All right, so you're in 2168. So right now I'm going to go ahead and deal with the whole syllabus administrative stuff that we typically deal with here. First things first, all the information that we really care about is on Canvas. Okay, so log in. So you can go to Canvas. And I happen to read that I happen to read the course image requirements, and they do allow me apparently to upload an animated GIF. So, you know, I'm not sure why they thought that was a great idea, but they don't seem to really care what I upload either. So, anyway, so this is the page. You've got. I'll publish announcements here occasionally, especially like when it's time for exams or there's practice exams for you to take or something. And what this will do, besides being an announcement over here, you'll get an email shot from Canvas to here. The best way to communicate with me is via email, but if you send me a message via Canvas, it will come in my email, so I'll get it that way. And unlike other systems, one thing I do actually like about Canvas is that if I reply to that email, it does send you a message back, which is fantastic. But email is generally the best way, and I will try to get back to you. All right, so other things are, let's see. So you'll find your assignments over here, basically the lab work that you have to do over here, and I've already posted something, and we'll get to work on that today. Grades, you can find that there. You can find the syllabus under syllabus. The most important page is the pages page, which has 3 links. First is a link to a YouTube video on the YouTube channel Crash Course. It's about 10 minutes long. Don't need to watch it, but it gives you a nice 10-minute overview of actually what this class is all about and a lot of the concepts we're going to be learning in this class. It's actually ridiculously informative for the short amount of time it is. Great. Next is this link, which if you click it, brings up a page with the link in it to my GitHub page, which if you look over here, and this is where all the code will be stored for that I do in my lectures or in my recordings. And specifically, it's going to be in the dstruct folder, short for data structure. And I try to organize it as best as possible. All the code, by the way, from fall 2017 and spring 2018 are in the respective folders, so you can check those out there. It shouldn't be too different. And I upload everything I try to organize basically all the content into the respective folders. All right. Third is the lectures page, which we'll talk about, which leads into the next part of basically the big thing about this class, which is the flipped nature of the classroom. Okay, so first you can find this lecture. So this class is a flipped class, meaning that I will be posting YouTube videos or videos on YouTube, and you're expected to watch them before coming to class. Okay, sounds like a bunch of extra work. It's not. The flip side is that this 2.5-hour block of time is essentially used as an extra lab section. This is the same way it's going to work for all the classes, by the way. Monday, Wednesday, Tuesday, Thursday. Sorry, not Monday, Wednesday noon, and Monday, Wednesday afternoon, right? So those classes are flipped, but they happen to have to break it up, so that kind of gets disruptive, whereas you get basically a full amount of time to work, which is great. Ideally, this should not incur any extra work because some professors are jerks and they will upload like ridiculously long, a ridiculous amount of content for you to watch every week. I'm proposing no more than 2 to 3 hours a week of video watching, and it's broken up into 10 to 15 minute videos. that means that basically you can watch a digestible chunk of information, take a snack break, come back and watch another video, right? It's not going to be so tough there. So you'll be watching videos as I upload them. The first like 6 videos or so, like representing like the first class or so, and a bit, are just review from 1068, which is also what our first assignment is, just to get you back in the swing of things if you haven't been programming all summer, right? Or haven't been, which is understandable. It's been a busy summer. But basically by doing a lot of work in class, so it's flipped in the sense that basically you're doing your lectures outside of class and your homework in class. And by doing your homework in class, you have more opportunities to interact with me, and I can actually answer your questions in a much more one-on-one fashion than you would get in a lecture, right? It's a better use of my time and your time, I feel. It doesn't work for every class. I feel like it's going to work for this class. I flipped a few lectures last semester, a couple weeks last semester. They thought it was very helpful. Now, that being said, so first off, I have I have 2 playlists here. The first is going to be stuff that basically I record outside of class, the stuff you're responsible for watching. This second playlist is the recordings I do in class. So me going over the syllabus is going to be in this playlist. This is useful in case you're sick and you miss class and you want to know what happened. And that's not going to be too much because, again, most of the time what I'll do is I'll ask you, hey, was there anything you didn't understand in the videos? Or if I discovered there was something that a lot of people didn't understand, I'll give a short clarification over here, right, in class and do that. The other thing that class time will be used for is like 10-minute quizzes. I'll get into those. Also, for reference, I have all of spring semester's videos posted here, where those are traditional in-class lectures. Okay, so they're about like an hour, so they can be like up to an hour long and the like. So you can check those out as well if you need additional resources or see if I explain things any different. So I just try to give you guys as many resources to succeed as possible. Okay, with that being said, let's go ahead and just try to quickly go over the syllabus so we can get into our first assignment. Okay, so first, come on, you can do it. I don't know why you're thinking you can't do it, but you can open. It's not very hard. Okay, we're going to try this again. My computer apparently was, I guess, striking. Okay, so syllabus. All right, so this is the syllabus for the course. My email address, pretty easy to remember. My first name dot my last name at temple.edu, right? So these are the topics we're going to go over for the course. This course is about organizing data in meaningful ways, in ways that we can, in ways that are useful for us, in ways that we can. So this is all about organizing data in different ways to solve problems. Some problems require us to organize data in one way in order to solve it efficiently. Other problems require us to organize data in other ways. So the first week or two will be focused, first week essentially we focused on inheritance and picking up and learning about generics. It's a feature, so you should have already learned about inheritance from last semester, the whole extends keyword. It's okay if you didn't learn about interfaces. I assume that there was not enough time last semester for you to learn about interfaces, and I go over them again. I certainly don't assume you learned about abstract classes, and I only briefly go over them. But I mentioned a couple of things that you may have missed, like the super keyword, or using this to call another constructor. Generics are a feature of C++ and Java, and they're fantastic for programming languages like Java and C++. They allow you to define, basically, this isn't just a collection of stuff. This is a collection of integers versus a collection of strings, and prevents you from shooting yourself in the foot by accidentally adding stuff of the wrong type. So you don't have to cast stuff anymore. It's a very useful feature, and you miss it when you really need it. So that's essentially the first week. The next couple of weeks will be spent on array lists and, well, basically all about lists. Array lists, linked lists, as well as going over computational complexity algorithmic efficiency. So basically getting a layman's introduction to big O notation. My plan is not to give you like a formal mathematical definition. That's reserved for like Math Concepts 2 and algorithms if you take that class. This one's giving you basically, I'm actually more interested in like a more practical use of big O notation. Looking at an algorithm and being able to spot that this is the computational complexity of this algorithm or this data structure and and more importantly, what that means. Okay, getting more of a feel for it. But most of it will be focused on array lists and linked lists. Now, interestingly enough, these items will take about the first 4 to 5 weeks of our semester, which is in time for your first exam. Your exams will be on week 5 or 6-ish, right? Week 5 ideally for me, but I've been known to push it back to week 6. This is week 1 for reference. And then your second exam will be around week 10 or 11. And depending on whether or not it gets pushed back, you might get stacks and queues. Now, array lists and linked lists, part of the reason I spend a lot of time hammering those subjects is because once we get them down, stacks take since stacks are simpler version of array lists or linked lists, and same with queues, from a design standpoint, from a building them standpoint, they're completely different, but building them uses the same techniques we learned. They take about a lecture to a lecture and a half each. So they're not really, so they're much easier. Then we'll hop on recursion. We're going to be solving stuff like mazes. We're going to be solving stuff like typical chess problems. How do you write something that like solves a Sudoku puzzle? That's generally pretty fun. So we're going to be looking at very different, basically how recursion takes really complicated problems and turns them into less complicated problems. Then we're going to look at how we organize data using trees. Specifically, we're going to learn about binary search trees, heaps, and Huffman trees, which gives us an introduction into compression. And basically, how do we take some data and shrink it, right? Like how do I like make a zip file and that kind of thing. So the Huffman trees basically build on that, on our knowledge of trees and show us how to basically encode data. Then we'll also do an aside into sorting algorithms, just to simply, because this is a good place for it in your education. Then we're also going to cover hash tables and and building sets and maps with hash tables. Hash tables are sometimes called maps, sometimes they're called dictionaries, sometimes they're called associative arrays. What they all mean is that basically we're creating a data structure through black magic and cheating, and they are extremely efficient most of the time. And I always get excited when I talk about them because my research topic was distributed hash tables. And then finally, graphs at the very end. I assume you haven't dealt with graphs yet. That's okay. I'll assume, but we're going to basically learn the basics of graphs. And of course, since we're learning graphs, that means you have to learn Dijkstra's algorithms. You will not take a class in which graphs are mentioned and not learn Dijkstra's algorithm. It's like you'll probably learn it like 3 different times over the course of your curriculum, and everybody's going to assume that you were not taught it before. That's par for the course at basically every single university, even at the graduate level. I don't know why that is. All right, and I just simply mentioned that these things are flipped. You found the time, you found the place. I don't know why I have to put this in the syllabus. It's on your course schedule, so I don't know why it needs to be in the syllabus. It seems redundant. Please attend the lab scheduled for your, please attend the Thursday lab at 5:30. If you cannot, and I'll go into this, if you cannot make it to a lab or a lecture, well, just email me. We're going to be adults about it, Okay, your prereqs, I have a typo here. You may not be prepared if you had only had a C in 1068. That should be 1068, not 2168. Okay. But you should have gotten a C in 1166 or 1068. If you had a C in 1068, if that was because you had a poor work ethic and now your work ethic is better, okay, you might be good. I mean, I'm guilty of that. I was totally a terrible student for my freshman and sophomore year, so it happens. But if you struggled with a lot of the concepts, if you didn't spend time studying over the summer, you may really be in for a struggle if you don't put in a lot of work during this first couple of weeks. All right, our textbook is Data Structures, Abstract and Design using Java in 3rd edition. Now I saw somebody with the 2nd edition of the book here, right? Can I pick it up for a second. So this is the second edition of the book. It's perfectly fine to use if that's what you have. Third edition, second edition, perfectly fine. There you go. So I just wanted to show that's what it's looked like. Okay? The big change for the second edition to the third edition is that the third edition corrected some minor errors that I only knew were errors because I was teaching the course. And they occur in later chapters. I think there was some error relating to heaps. And then they took the third chapter of the second edition and compressed it, and they moved it into the fourth chapter. So chapter 3, it went from chapter 3 being stacks and chapter 4 being queues to chapter 4 being stacks and queues. And now chapter 3 is a great chapter on testing your code, debugging your code, how to run stuff with JUnit. And that's something I hope to get into if we have time permitting. I'll cover pretty much. I'm going to try to cover everything in the book except for chapter 9 because there's time constraints with that. Chapter 9 though, that doesn't mean you're not going to know anything about what's in there. Chapter 9, self-balancing trees. You're going to know about the generalized concepts of that. You're going to know about it will learn the first section of that. And it's just we don't go into like how to build a self-balancing tree simply because we cover a lot of stuff already. My office hours are circ 3:49. My office hours are Monday, Wednesday, 2:15 to 3:15. Now I know since you're taking an evening class, that may not work for all of you, especially if you're taking this because you're working, right? This is just simply my office hours where you don't need an appointment or advance notice. You can just drop in, and I literally will drop what I am working on to help you, okay? If you need to meet with me outside of those hours, just tell me. Send me an email. We'll discuss a time that we can both be on campus. If we both cannot be on campus, I will make time to meet with you, preferably via WebEx, and that way we can video chat. And WebEx is something that Temple has contracted through, and that gives me so I can just send you a link. You can click on it. We get in, and then we can chat, and I can control your screen if I need to, with your permission, so that I can make some adjustments to your code. Although it was really weird when I was doing that with some students in Japan, because their keyboards are completely different. So I was I was trying to, type in parentheses, and the parentheses are on 8 and 9, not on 9 and 0. So it's really weird when you're trying to use a completely different keyboard. All right, so our TAs, you have one TA for this course. I believe that's Heng Fan. I've got to put in the office hours and his office location. The TA stuff is up in the air. That's just the TA who's going to be present at your labs. You can go to any of the TAs listed here, and any of their office hours listed here. Okay. My TA situation with one of my TAs is up in the air right now because of various bureaucratic reasons. But any of the TAs with their office hours and their office locations, you can go to them if their times work better for you, right? So. Because they're going over the same exact content, right? It doesn't make sense that you can't go to these TAs, okay? So attendance, I expect you to be both here for the lecture and the lab, especially since I'm going to be doing quizzes. If you arrive late, just do your best to just, don't be super dramatic about it. Just, be an adult about it. Also, I happen to have a habit of mentioning what's going to be on the exam, up to and including actual questions that will be on the exam, so that's kind of useful to be there. If you're sick, don't come to class. Just send me an email. I'm going to be recording these things anyway, so watch the recording. Just send me an email. I'll give you a chance to make up the stuff if you're sick. That's it. Same with an exam. If you're sick, don't drag yourself to an exam and fail the exam because you're sick and you couldn't study. Send me an email, tell me you're sick, schedule a makeup exam. Okay? Don't get sick, I guess, every week and on every exam and every mini exam there is. Don't do that. That's kind of, I might start having to ask for proof then, and that just becomes a bureaucratic headache for everybody. All right, this is the generalized don't cheat statement because plagiarism detection is an actual assignment I could give you guys in this class. I could give you an assignment that says, please build a plagiarism detector. That's why rates of plagiarism are higher in computer science, in my opinion, because computer scientists kind of write all the software that does that plagiarism detection. Not necessarily because other subjects plagiarize less. I just feel that computer scientists can probably detect it a bit better. Don't plagiarize. When in doubt, and this goes for every class, provide a citation. Okay. Also, you're going to be working with others. A lot of assignments, these are going to be paired assignments, right? Part of why I don't necessarily expect everybody to have a laptop that will work all the time. I'm hoping that's the case, but I'm aware of that I'm dealing with real life with people who have budgets, right? But anyway, how that goes with group work is that basically if it's a pair exercise, you both can submit the same thing, obviously, because you both worked on it, right? Just don't if it's an assignment you're supposed to work on by yourself, don't email somebody else and say, hey, I'm having trouble, can I see how you solve this problem? Then take what they did, simply strip off their name and submit it as your own, right? Also, if you happen to be one of those students, please don't do this. Don't upload my stuff to, upload my stuff online to like Course Hero or their other websites. Just don't do that. It's unprofessional. And furthermore, when you do upload it, be smart enough to remove your TUID from the comments. Real story. All right, so I will be recording these things. They'll be up on YouTube. I use YouTube not because not because any of the stuff that Temple provides is terrible. I think Panopto is actually pretty good, but this simply means that that if it's on YouTube, it's easy for you to find. There's a lot more ways you can work with it, and generally, if it's on YouTube, you can. The connectivity problems are not my fault anymore. So if you can't access YouTube, it's not my fault. All right, grading. Generally, you need above there is generally a curve at the end, but it doesn't necessarily help you if you're below a 70. If you're below a 70, you're probably not going to pass. The curve, what that generally does is that it makes it so that basically it adjusts the range of the score that you need for an A. If you get a 90, you're guaranteed to get an A. Okay. If you get an 88, it just depends on how the scores work that semester. But I have a don't be a jerk policy. So if you have an 89.5, right? If one person has a 89.1 and they get an A, and you have an 88.8, you're probably going to get an A2 because I don't really see much of a difference in a 0.3. If it's a 3-point difference, yeah, you're probably going to have a different grade. Okay. So the grades approximately weighted. I don't think I'll change this simply because I don't like changing the weights afterwards. Your labs and assignments, which are the same thing, labs and assignments, think of these as basically anything where you have a long-term deadline, right? A week or so. That's 25%. That's a quarter of your grade. Quizzes. Those are things with a really, really short deadline, like 10 minutes. Those are about 10% of your grade. Quizzes, though, I try to make them as stress-free as possible. I provide a good portion of the points, from anywhere to a quarter to a half. Well, let's say, fifth to a half of the points being like free points just for taking it. So that way, just by taking it, you get some points on these quizzes. Now, these quizzes, I don't like grading a lot of short exercises, so they're going to be auto-graded, so there's going to be plenty of multiple choice questions. There will be some coding-like questions, specifically what are called parson puzzles, where you will have to select code from drop-down menus and arrange the code in the proper order. And that helps you, that allows you to write code without actually having to write code, and then it can be graded automatically. Timed labs are about 10%. Think of these as mini exams that will be taking place on around like week 3 and week 7, and then right before the final. These are about 3, so there will be 3 of them, so they're about 3% of the grade each. They'll give you a pretty good idea of how prepared you are, or how well you're keeping up with it. And if you bomb one, well, it's 3%. That's not great, but it's at the same time, You can do better. Unlike exams, which are on paper, these will actually be done on the computer, right? You'll be able to use your computer with your IDE, to solve these things. And I am open to arguments to allow you to use certain websites even, except for Stack Overflow. So, all right, so that covers that. The only last thing I really have to cover is the turning in process for homework. It's a two-part process. For part one, you submit it online, upload it to Canvas like every other professor. Part two is how you actually get your grade, because submitting it that just simply gives you a timestamp. Then the second step is demoing it, showing it to me and your TA. That way, you'll get a grade basically as soon as you demo it. That way you're not waiting weeks and weeks and weeks for a grade. The demoing it means you come over to me, run your code, or the TA as it may be, and then we ask you a question about it, ask you to walk us through a certain part, ask you to explain it. And if you're having trouble for explaining some stuff later on in the semester, like linked lists, I highly suggest taking out some paper and just drawing what happens. That's perfectly acceptable. Explaining doesn't have to be completely verbal. You can feel free to use pencil and paper, and I advocate highly for using that as much as possible, or putting in comments so you can refer to them. That's what will get you your grade. Now, because coming to a professor and explaining your code, coming to the person whose literal job is judging you and your work is very nerve-wracking, right? I don't grade you based on how well you explain it. I just simply grade you on whether you can explain it or not. If you cannot explain it, I simply tell you to go away until you can, and come back and do it again later, okay? Because, it's tough and intimidating. But it also serves as a basic way of basic plagiarism detection. Eventually, I can look at your code, and if I've seen that before, then I've seen it before, right? And even if I haven't seen it before, if you can't explain it because you plagiarized, well, that's an issue. All right, so we do accept late work. It is done by this slightly intimidating equation, which simply means 5% off per day. Not 5 points, 5%, meaning the first day is 95. First day late is 95 points. Second day is 90.25. So you lose. This means that basically you can turn in something and it's always going to be worth points, right? It's always worth something. Although if you're turning it in more than 10 days late, I need an excuse, right? I need a reason why you didn't do it in 10 days. Okay. All right. And exams, study for those exams. I do provide practice exams. They are very good representations of the actual exams, because what I do is I make twice as many questions as I need, put half of them in a practice exam, put half of them in the exam. So right now you've got half the questions that I wrote for an exam, and you can test yourself now. It's very good representation. Okay. The final exam, I have to update those dates and time, and I'm going to get them from the exact same place you do, which is the academic calendar, right? But note that since you're in the evening question, you may or may not take the common final, but you'll be taking it not during the common period. You'll be taking it here, right, in an evening time, okay? So I might change this. I'll announce it when I do put up changes. You have rights, such as you're only limited, like you have rights, such as you have a right to how many finals you are allowed to take in one day. The answer is 2. You can only take 2 finals per day. If you have to take 3 finals due to scheduling reasons, you are allowed to ask one of the professors to move and give you a different time to take that final. So there's all sorts of interesting things you can find by clicking on this link. And then I have a bunch of tips for succeeding. All right, with that being said, I'm going to stop this recording and I'll start up another one because it's time to talk about our program. All right.